This first chapter today is Module 11 on managing master detail forms, and we've also got another topic in here that goes along with that about something called multiple dialogues. I don't think we've really talked about multiple dialogues yet in this class. We use the term dialogues, you probably noticed, for several different things in Genero. So far, when we've been talking about dialogues, we've been talking about the interactive dialogue statements, right? Like display array and menu and construct and input array. Those are all examples of dialogue statements or interactive dialogue instructions, if you want to use the really long term for that. Well, in this chapter, we're going to get into a few different ways that we use the term dialogue. Now, we're still referring to the idea of these interactive dialogue instructions. We're still talking about those, but we just use the word dialogue in different ways. So we're going to talk here about the term multiple dialogues, and the idea here is that we can have multiple interactive dialogue statements that are nested under an overarching parent dialogue statement. And then what that does is make the user able to move around freely between these different interactive dialogue statements. You know, typically if I have like let's say an input array and a display array in an application, the user has to finish with one interactive dialogue instruction before he can work into the next interactive instruction. But with multiple dialogues, they're actually able to bounce back and forth. So if I have a master detail form, like we're going to talk about in this chapter, he can move between different parts of that form freely without having to select accept or cancel to be able to do it. So that's what we're getting into this morning. So first we're going to start off talking about master detail forms. So if you've looked at that Office Store sample application that comes with your installation of Genero, there's this Office Store project. And so far we've been looking at the account application some, and we've been working with the database all week for our little applications that we're writing. But there's an orders application in that project down towards the bottom of the project tree, and you can execute that application, and it has a master detail form here with information from multiple tables. The user here, this might be a couple of input statements here and maybe a display array down here, and the user can pop around and click in these different parts of this form because they're using this technique of multiple dialogues. So we're talking about these master detail forms. We're focusing in on that part for this part of the chapter. So let me just, instead of walking through these PowerPoints, we'll just go ahead and do one. I'm just going to save mine temporarily to this library node here. So we already know how to create a new form. We've learned that already on I think the very first or second day using this form from Database Wizard. So let's assume that I've gone in here and created a form. We'll just use some account info since that's what we've been working with the most. So I'm just going to grab a few columns here from my database to create this form with. First name, last name, and I'll call it good there. And for this container, I'm just going to select the default, which remember is just a grid container that's intended to display a single record at a time. And that's fine for what we're doing with this part of our form. So this should look familiar. We've worked with forms quite a bit this week. But this time I'm going to create a master detail form, so I'm going to actually extend this form so that I can add some information here about orders to it later. So to do that, I'm going to extend my form, and just so you can see what I'm clicking on, let's go over here in the structure view. Notice I've got the form node selected, and I'm just going to drag that down a little bit. I'll do it this way. There we go. So all I've done here is just extended the form to give myself some space down here to add some additional containers and information. So now I'm going to go up to this container menu option, and down at the bottom of it is a data control option. So the data control is just another wizard It looks just like the form from Database Wizard because I think it probably is, right? It's probably the very same dialogues. This time, though, I'm going to pick some order information. So my accounts have orders. So I'm going to pick just a few fields here, like the order ID, maybe the order date, and maybe a total price. So I've picked some fields there for order information for my account, but instead of picking a grid this time, I'm going to pick a table container because my account might have multiple orders, so I might just want to display those as a list. So to do that, I'm going to pick a table container, and then I clicked Finish. So notice now that my icon is showing that what would you call that, kind of a target symbol. But anyway, you can tell that something's going on there. It's waiting for me to draw this in. So I'm just going to draw it in and let go. Right? So I just held the left click option there and dragged and dropped this new part of the form, this form extension. So now I've got my table container here underneath my form. If you remember from the last couple of days, I think we've talked a bit about building forms. If I tried to compile this form now or preview it, notice those options are grayed out. So if you remember, one of the things you have to do if you have more than one container in a form, we have to specify a layout for the form. So I can't just leave it this way. I'm going to go back over here to my form. I'm going to close these so we can see them better. And you can see my two containers here. I have to specify either a horizontal layout or a vertical layout. So I'm going to select both of those. I'm going to right click and I'm going to select a vertical layout because I want them one underneath the other. So now you can see this orange area of the form tells me that I have a vertical layout going up and going down. So now if I go over here, I should be good to preview the form. That's what it looks like now. So I've got some account info up here at the top of my form. And this, of course, is just a grid container. And then down here at the bottom, then, I got my table container where I can eventually list out my order information for each account. So that's just some quick information there on creating a form that you can use with master detail type applications. I'm just going to delete that because I don't need it for anything. I just wanted to show you steps that you go through to create it. So that's a master detail form. So now we have two wizards that we have to remember. We've got that File New option that we use to create the form initially, that form from database option that we have there. And then once you're ready to extend the form, then you use this data control wizard so that you can extend the form. And don't forget to grab the form and drag it down to give yourself some space, because if you don't, it ends up pinched up against something else, and sometimes it's hard to grab that and pull it away. So it's easier if you just go ahead and extend the form first by dragging it down like I did, and then run your data control wizard and pop it in there where you want it with the mouse. All right, so we had already talked about all of that while we were going through it live. So that puts us here in this another section on working with what we call Zoom modules. Basically, what we're doing here is we're using a button edit. So a button edit widget, we have the ability to add and associate an action to that button edit widget. And then if the user clicks on that button, it fires the corresponding action handler in the code. So that's what we see here. Somebody has gone into, it looks like select an account. Yep, this is just accounts, an account. And they had a button edit. They could click on a little button, and that in turn ran a function that actually displayed an additional form and then used an array here to list out all the different accounts. And then the user could just select one of these rows from the list, and that gets returned then back to the underlying form field. So a button edit widget is just another one of those user-friendly widgets, data handling widgets, that make it easier for a user to input data. So the same thing here. Let's look at a Zoom module. I've got one here for us to look at so that we can see it in more detail. So up here I've got an application called Account Zoom. Let me just run it first so you can see how that looks. Alright, so first I'm going to do a little query here to pull up some rows from the database table, and then I'm going to hit the Modify option, and then right here you can see we've got a button edit here for this country form field. So if the user clicks on that, that brings up this Zoom form, pops this up, and then the user can scroll through all these different countries and pick it in a bit more friendly way than having to just type it in. Now I've selected it by just picking from that list, and then of course it returns back this variable that ends up being put into this underlying form field. So that's how it looks. I'm just going to cancel out of that. So now let's take a look at how this was done. So right here is my form, this Accounts All form. Let me pull that up. Here's this country form field. So if we look over here, that's been converted to a button edit. So remember how you can convert any of these widgets using the right-click option right here in the form structure view, and there's a Convert Widget menu option. So I just went in here and changed what was originally an edit field. With this Convert Widget, I changed it to a button edit. So that's pretty easy to do. So once then it's been converted, this account.country was converted to a button edit, the next step is to go down towards the bottom, and there's a miscellaneous properties group down here at the bottom with an action property. And notice you just make up an action for that. So the action I made up is Zoom_country. And now you just have to make sure that in the actual application that you remember the name of this action. So I always write it down. If I don't write it down, I always get it backwards or something like country Zoom. And then of course the action is never enabled, right? The action view, the button edit in this case, wouldn't be enabled. So make sure the names match here in the form, and then also of course in the actual action code, right? The on action clause in the code. So now let's look at the program. And somewhere in this application we've got this on action Zoom logic in the program. So this is a good place for me to show you something else that's handy. In the edit menu option, there's a search and replace option. So I'm going to click on that. And here's this search and replace view now that I've got down at the bottom. And I'm going to see if I can find that a little faster than just scrolling through the whole program. So it found it really easily. Notice up here it's already found it, line 217. So I'm going to get rid of that now. But you can leave that up all the time if you want to, so whenever you're looking at your code, so you can quickly find things in the code without having just to scroll through the whole thing. So here we are in a input, I believe. Yep, here's an input statement. That's what we were running in our code. We were letting the user modify information about an account, so that was an input. And in here in the input, we've got this on action Zoom country. And of course this is the part that I said has to exactly match that action property that we saw a minute ago in that miscellaneous section of the form properties. So our button edit had an action property called Zoom country, and then that is bound to this on action handler with the name Zoom country here in our on action clause. So on action Zoom country, we just got one line here. Let mr account rec.country, that's our underlying program variable, right, or record member for country, equals whatever comes back, whatever the result is of this function country list. So let's go find the country list function. If I don't find it pretty quickly, this would be another case where I would use that find. There we go. I had it marked, in fact. Function country list. You can see here if you had worked on the lab For the display array, this would be just almost exactly what you would have done in your lab. So this would be very familiar code to you today. So we looked at this yesterday when we were talking about arrays in our array chapter. So here we've got a function where we're defining a dynamic array of records. We've got two members in our record. We've got code, which is defined like the country table code column, and in code description like country.code description. And that's pretty much it. And then we've got just a regular program record, country rec, that's defined exactly the same way. So here we're opening a window, and one thing I didn't show you is the form. Let me grab that real quickly. Right, so when that list of countries came up, we were just looking at an additional form. So here it is right here. We could use that file, new form from database wizard to create this. So it's just got two fields in it, country code and country description. You can see that over here in our form structure view. So just a brand new form created with the form from database wizard. So we're opening that here. Open window W country with that form zoom country that we just looked at. And since we're pulling all these country codes and country descriptions from a database table, we're declaring a cursor for that. And then right down here we've got our for each statement that we learned about yesterday to populate the array. So there's two ways to do that. Here's these special methods, array handling methods that we learned about yesterday. Right? So we're adding an element to our dynamic array with this country array.append element method, and then once we've got this element added to our dynamic array, then we're setting that element's value equal to our program record values. So we're just doing that with a for each statement until we have gone through the complete list of country records that were returned by that cursor. And then once we've got our array populated, we're just using this display array statement to display it to that form, that zoom country form that we saw a minute ago. And then right here we've got the logic. I think we saw this yesterday as well. So the user selects a row in the screen record, and we're identifying that selected row here with this statement, array current, and then we're returning that. Well, we're setting a variable to that value in the program array, and then we're returning it right down here to the calling function. So that gets returned back to the calling function, and then that gets stored in the underlying form field. We've got that unbuffered. Remember in our input statement we use that unbuffered attribute to make it sensitive, so when we return that back and store it in our program record, then it also gets updated then to the form field. So pretty straightforward. It's basically all the things we learned about yesterday, but we're just applying those things in a more realistic manner with this Zoom form today. Right, so that's pretty much everything about a Zoom form. So here's just going through the Zoom module and showing you what it looks like. There's the display array. Here's the button edit widget with the action property that we just looked at a minute ago. And then in the code, we have to have a matching action name in the code, Zoom1 in this case. And then our logic to call a function that displays our form with our data using a cursor, and then allowing the user to select from that and returning back the selected value. This is switching gears here, still talking about this idea of working with a master detail form. And here we're talking about using multiple dialogues to allow the user to move between the different parts of the form without having to accept or cancel out of the part they were previously in. So we do that with something called multiple dialogues. And there's actually a special dialogue instruction for that that lets us create a parent dialogue with multiple nested sub-dialogues. Sounds very fancy, but all it is just a dialogue statement with an end, and in between the beginning and the end of that statement we have multiple other interactive instructions like we've been learning about all week. We might have an input array and a display array, or two input arrays. Doesn't matter. The whole concept is just whatever interactive instructions we want the user to be able to move between freely, we're going to nest inside this overarching dialog instruction. So the programming steps for that, we're going to create a form with screen records and screen arrays, if you're working with arrays. Define program variables, records, and arrays. Open and display the form. Fill your program variables with data. Essentially, steps 1 through 4 are just talking about working with your regular interactive dialog statements, like your input array or your display array. So there's nothing new about those steps. You're just implementing your regular dialog instructions. Then step 5 is where it gets different. Step 5, we've got this implement the dialog instruction block to handle the interaction. And then you would define your sub-dialogs in between that. So we've got our dialog instruction block, and then our sub-dialogs go between the beginning of that instruction block and the end of that instruction block. You can still control your behavior with all your usual control blocks that we've been learning about this week, like a before field, after field, all of those types of control blocks that we've used to manage what the user's able to do in a dialog statement. But we have a few new ones. We have a before dialog that we use with this special dialog instruction block, and then we have an after dialog. We also have an accept and exit dialog as well. And of course that's how you exit out of this dialog instruction block. You need to either accept or exit. Accept just means that, for example, if there's an input or an input array instruction inside your dialog block, it's going to do the typical validation to validate the values that are input and then exit out of the dialog block. If you use just a plain old exit dialog, there's no value validation done. It just simply exits out of the dialog block, and any other subsequent instructions in there, it just skips over them. So that's the case actually for both, right? If I say accept dialog or exit dialog, there's not going to be any additional instructions executed inside that dialog block. It'll just do, in the case of accept, it'll do your field validations and input validations, that type of thing, and then exit to the next line after the accept dialog. And then if you use exit dialog, it just simply exits out of there without doing any validation. So a sub-dialog, we use the term sub-dialog, is really just a dialog statement. A sub-dialog just means that these are dialog instructions that are inside of an overarching dialog block. So it can be inputs, it can be display array, input array, or construct, all these different instructions that we've talked about this week. So here again is that orders application. This is that form that we looked at earlier to talk about a form that was a master detail form. So since that was a master detail form, there's different parts to that form that are controlled by different interactive instructions, interactive dialogues. So this part of the form is handled by an input statement. This part of the form down here is handled by an input array. But the user can move between these two different parts of the form, like bounce through here and look at the first name and last name, and then go down here and click and scroll through this information, looks like details on the items, without having to cancel out of this part or accept this part. So here's some example code, and I've got another example for you, that just a short application I'll show you. Up here at the top is this new statement that we're just learning about in this chapter, this dialog statement. So there's a beginning and an end to it, right? We've got the dialog, and then down here at the bottom we've got the end dialog. So in between the dialog and the end dialog is where we have our sub-dialogs, which are really just these dialog statements that we've been learning about earlier this week. So here's our input statement, and you can see it's quite a long statement, so I've just used the little ellipses to show you that there's a whole lot more code here. So there's an input, and then down here is this input array. Now, one more thing about dialogues is a new feature. It's only been here a couple of versions. Came out in Genero 250, so it started there. But now you have the ability to create a library of interactive dialogue statements. Basically, you're doing the same thing as you would like a module of function that you wanted to reuse. Well, this is a very similar thing to a library of functions. You can just create a source modules, like this one's called orders.4gl, and you can define all of your dialogues in here as what they call declarative dialogue blocks. So essentially you just use the keyword dialogue in dialogue, and notice that it's at the same level as a function. Right? So it's very much like a function. If you look at the structure of it, the only difference, I guess, really is I'm not allowed to pass this dialogue block any parameters, right? So there's no parameters allowed, but notice I can define local variables inside this dialogue block. So I think of that just like I do a function. It's at the same level as a function. These are reusable dialogue blocks, and I can reuse these by just calling them by name. Right? See this name, orders_DLG. So that's called a declarative dialogue block. You're essentially creating a library of dialogues that are reusable so that you don't have to rewrite the code to display array such and such. So then over here on the right-hand side is what they're calling a procedural dialogue block. And that's just what we saw earlier, right? The procedural dialogue block is just using the dialogue statement in the code, like we saw in the previous example, to nest multiple dialogue interactive statements, or sub-dialogues we'll call them. So here's the dialogue statement, down here's the end dialogue statement, and then here we have one local dialogue. It's an input by name. And then under here, if you look, we've got the sub-dialogue statement that's naming this one over here, orders_DLG. So there's another new statement. So this is a method that we can use to more or less invoke one of the declarative dialogues that we have in our library of dialogue routines. We can think of it that way. So it's a reusable dialogue over here in a separate module, and we can use it by more or less calling it with this sub-dialogue statement. Passing a dialogue object to a function. So I guess one thing to think about is dialogues like an input or an input array, display or display array. All of those are really just objects to Genero, just like a window object or a form object. So since an interactive dialogue is just an object, that means that we have methods that we can apply to those dialogues. It's smart enough to be able to figure out what the current dialogue is. So we have a special predefined dialogue object called dialogue. I mentioned earlier we use the word dialogue for a lot of different things. So it's real easy to pass a dialogue object to a function. Notice I don't have to define any variables to hold the reference to the dialogue here. I don't have to get a reference to the current dialogue. All I have to do is use the keyword dialogue, and it will figure out what the current dialogue interactive instruction is, and then I can manipulate elements of that dialogue or objects within the dialogue. Now what they're saying here is I can pass a dialogue object as a reference to a function. I can't use this keyword dialogue outside of the dialogue block. If I do, I get a compiler error. Right? So it won't actually let me use the word dialogue anywhere outside of the dialogue and the end dialogue. But I can do this. I can call a function from inside that dialogue block, and then I can pass the current dialogue by reference with this keyword dialogue. So down here there's a function outside the dialogue block, and it's being passed a reference to the current dialog here, which it's storing locally as pdialog, which has been defined as a UI.dialog object. And now I can manipulate elements within that dialog using that reference to the current dialog. So in this case, I'm saying set field active orders.orderID. This is by the way, this is just an expression, and once that expression is evaluated, it's going to be a Boolean. So it's either going to be true or false, 0 or 1, and that determines whether or not we're going to set this order ID field to active or not. And by active, we mean it'll either be grayed out where the user can enter that field, or active so that they can enter that field. Now we'll actually talk more about that in the next chapter. The very last chapter is just kind of a discussion on all these different built-in classes and class methods that we have with Genero. If you're familiar with Informix 4GL, the language looks very similar, but the 4GL, of course, doesn't have all these nifty classes and methods that we're starting to look at here. I mentioned that a couple more new commands that go along with these dialog instructions is the accept or exit dialog that we use to exit out of the dialog block. So if you're working or interacting with the user, perhaps he's entering data in one of the sub-dialogs in the dialog block, then you can use this accept dialog, which will go ahead and do any field or validation that needs to be done based on whatever interactive instruction that's been used. And then, assuming everything's okay, it will go ahead and exit out of the dialog and start working on the next line of executable code after the block. Otherwise, there's an exit dialog that you can use. And in this example, it's a pretty good example. You can see here the user has canceled whatever he was working with there, whatever interactive instruction. And since he canceled, we don't want to do any validation, anything of that sort, so we're just simply exiting the dialog and going on to the next line of executable code there. So that's accept and exit. All right, so that brings us to the end of the lecture. Let me just show you the little example here I think I've got. There's a little application here called MD-List. Sometimes it's easier to see what's going on with a small application. So let's take a look at it. Essentially here I've just got two lists. So I've got a dialog statement we're going to look at that's got two display arrays. I've just loaded up some data here and displayed it with display array statements. And here this is showing you how you can just move between these two sub-dialog instructions without having to accept or cancel out of one. So I can work over here and insert a value here. I can go back over here and append. So I can just move between them. Get rid of that. If you look at it, here we've got our main program block. This is all just stuff to define the arrays and load the arrays. And then down here, I've got what I consider my parent dialog statement here. Notice I can make the whole dialog unbuffered by using the attributes clause way up here at this level instead of on the individual dialogs if I want to. So here's the first sub-dialog, display array. Here we've got on action cancel, and I'm using the exit dialog there just to exit out of the dialog. And then here's the second sub-dialog, another display array. It's basically got the same code. And then down here at the bottom, I've got my end dialog. So my dialog statement here corresponds with this end dialog down here. So just a very simple example. So built-in classes, here we're talking about these packages that are built into the runtime system, meaning that you don't have to do anything special to use them, like import them or load them before you use the class methods. So we have several of these. We have base, OM, UI, OS, util, and so on. And we're just looking at this chapter as an overview of these different packages and classes, but mostly I want to refer you to the documentation for them. So let me pop up something so I can search. Point out that anytime you have any questions about classes and methods, you can just... So here's this UI.interface documentation just for an example, and notice how it breaks it out here by class methods up here at the top, and then make sure I don't miss them here. This has a, oh, you know what? UI.interface was a bad choice because they are all class methods. So let me pick a different one. So basically, we've got class methods and object methods. Well, I'm just going to grab one of these and go to the parent, and that'll put me in there. Okay, so like this form, UI.form class, notice here we have one class method up here at the top, so I can see that it only has one. And then down here are all the object methods. So all of the different packages and classes are documented very well, and so you can go out here and see how many class methods and what they are, and all the object methods. And if you want to learn more about a particular method and even see examples, you can click on that method and it'll open up more specific documentation for just that method. So, and a lot of times there'll even be an example in here. This particular one does not have an example, but a lot of them do. So I just want to point that out, that everything's very well documented with these. So if you have any questions about what methods are available to manipulate form items, for example, you can look at the doc to find that out. So in addition to these built-in classes that we've been talking about here, we also have a set of utility functions and extensions as well, so that we can implement our own C extensions, for example, or we can use Java classes and instantiate those in our BDL program. So we have the option to do that. Genero provides a set of utility functions that you can use. All you have to do to use those is import them, and then you can use those functions in your code just as though they were your functions written in the program. So we're going to take a look at some of those. So just an introduction to the idea of these built-in classes. I've already talked about this in the previous page, but built-in is just referring to the idea that it's already built into the runtime system. So they're just there and they're available. So if I'm using, for example, a class method is a method I just don't have to get a reference to the object beforehand. I don't have to define a variable to use a class method. I can just run the command, the method itself, to use it. That's all I have to do right there in the code. I don't have to import anything. I don't have to load anything to be able to use these because they're built into the runtime system. So a class belongs to a package, and all of these classes that belong to a package, the reason they're in a particular package is because they all have some commonalities. For example, we have like the UI.interface class, the UI.form class. Well, these classes are all in the UI package, of course, because they're part of the user interface. So we've got Windows, UI.window, UI.form, and they all have that in common. So they're all in the same package, the UI package. And then a class implements a set of methods to manage a specific domain, like the user interface, for example. The DOM node class provides methods to manipulate DOM nodes. And of course, with those methods, we have them broken out into the two categories, the class methods and the object methods. So here we're talking about class methods a bit more in detail. So I already said that a class method, you don't have to get a reference to an object before you can use methods that are class methods. You don't have to define a variable of type whatever object you're working with. You just use the class method all by itself, just like this one. Display base.application.getArgumentCount, which just goes out there and looks at the current application that you're running and gets a count of the arguments or parameters that were used when that application was executed. So here too you can see, go back to the syntax, the base is the package here, the package name, application is the class name, And then of course the method is the getArgumentCount, which in this case is a class method. Now object methods, of course, is a different idea. I do have to get a reference to the object before I can act on it with an object method. So to get that reference, I define a variable of the class type. Like with this example, it's a variable of type UI.window. So define W. W then will be a UI.window object. And then I have to create or reference the object using one of the class methods. So here we've got our variable defined here is type UI.window. In our code, we're opening window, win1 with form, just like we're used to seeing this week. And then right down here, we're using a class method, UI.window.getCurrent, to get a reference to the current window. Now, by the way, you'll see in a minute there's more than one class method we can use to get a reference to a window. We've got this method, which just says whatever the current window is, let's get a reference to it. And of course, we're assigning it to our variable W, which is a UI.window object. So now W has a reference to this current window. So now we've got a reference to it using this getCurrent class method, and now we're using an object method, setText, to change the title of the window. So now that we have a reference to the window with our variable W, we refer to W, setText, and now we're changing the title of the current window to new order entry. The base package here, talking about another one of these packages, kind of getting started, just an overview of some of the more commonly used packages. Here we've got, grab my highlighter, we've got various classes here, and you can see that the base package gets its name from the idea that we're working at things that are not really inside the application. It's more the operating system level, the application level, not really at the user interface level, so that they can have that in common. But the application class gives us access to the program. Like we saw an example of that a minute ago, to go out there and get the count of the arguments that were used when a program was executed. You can use an application class method to get the name of the application, that type of thing. The base.channel class is used to be able to, at the operating system level, we can read or write to files. I can read a file, I can write a file, or it could be a pipe. I can use a base.channel method to use a pipe and read from the standard out, or read from the output from that pipe. I think there's a channel method out there to open a socket. So those are the types of things you can do with the channel class, basically reading or writing. And then we've got two different classes here in the base package to work with strings. String handler, and then one for string manipulation. This string buffer class has methods in it that we can use to build a string, right, like create a string. There's methods in there that you can use to find specific locations in a string, like go into a string to a certain index value, like let's say the fourth character of the string, for example, and then return part of the string, like from a starting location, so many characters. That's the kind of thing you can do with the string buffer class methods. The string tokenizer class, it's more used to parse a file or something you pass into this class method, the class methods, to read what's in between delimiters. Like let's say I've got a comma delimited file. I could use methods from the string tokenizer class to go in and get the values from that comma delimited file and return all the values. So that's a way of, they call them tokens, right? Everything between two delimiters is considered a token. So you specify with the methods for this class what the delimiter is, comma, pipe symbol, whatever it happens to be, and then you use methods to go through and read what's between, return what's between those delimiters. So read a file basically by parsing through it. This last class, this type info class, only has, I think, one method. It's a very small class, and it's for variable serialization, like converting a variable to a DOM node, turning it into XML by creating a DOM node. And then you could use another method, I think from the ohm class. You could use that to write that DOM node to a file. With those two methods, you could serialize a variable into XML by creating a DOM node with it, and then you could write it to a file, an XML file, with another method. And then you could take that file and use it with any application that had the ability to read XML. A way of making values portable by converting them to XML. The UI package is probably the most commonly used package. That's where you see UI.interface, UI.window. These are all classes in this UI package that we can use to work and interact with the user interface. So of course there's classes here to work with windows, combo boxes, so we can load combo boxes with special methods. We've got class methods to work with forms in the UI.form class, and we have the UI.dialog class that we saw in the previous chapter that we can use to work with the interactive instructions, things like the input array, the display array, the menu statement. And that's where we saw, I think, one example already of being able to use this predefined object variable dialog to give us a reference to the current dialog. We'll see more of that too here as we go through the rest of this chapter. So here's some examples of methods from the UI.interface class. We saw just a few minutes ago when I tried to show you the documentation. I got in there to show you documentation on how you could see the list of class methods at the top, and then later there would be a whole section on object methods, but I picked the wrong class, right? I picked UI.interface, and of course the UI.interface wasn't good because it's all class methods. So I had to use the UI.form class to show you that. So there you go. The UI.interface class is all class methods, so they're very easy to use. I don't have to define variables to use these methods. I don't have to do anything to get a reference to anything to use these methods. I just use them right there on a line by themselves. So here we've got just an example here. We're just displaying a message to the user to standard out. That's what the display statement does. Type equal, and then we're just concatenating the results of this method, get front end name. So that should say something like type equals GDC, Genero Desktop Client. That's the kind of thing that method will return, the name of the front end. And of course this one down below is going to give us the version, UI.interface.getFrontEndVersion. So that'll return something like 3.00. such and such, the version of the front end that it detects. Some other UI.interface methods, and some of these we've actually seen in some of the examples this week, some of the sample applications. We haven't seen the load start menu. We don't talk about start menus in this class, but if you are in the class coming up in November, we have a whole module on start menus that the users can use to select the application they want to run. But we have seen, I think, references to this UI.interface.load toolbar. There's a load top menu and a load action defaults and a way to load your default presentation style. So I think we've actually talked about this previously. So we can define all these different resources, toolbars, top menus, action defaults. We can define all of those right there in the form if we want to. But we also have this option to load toolbars, top menus, and action defaults at the interface level by using these class methods. That means that any form that's opened will have access to these toolbars, top menus, and loading styles just means that anything in the user interface has access to these styles loaded at the interface level. So you can assign any of these styles to an object in the user interface, and they're available to everything if you load them with this method. So here's an example down here, ui.interface.loadToolbar. And then we're just giving it the name of our toolbar file in this case. Notice we don't have to have the little .4tb at the end of that. It's smart enough to figure out that toolbar files end with a certain extension. Same thing for top menus and action defaults. I don't need like the .4ad for the action defaults file. When I use this command, I just use the simple name. I don't need the extension. So here's this ui.interface.frontCall method that we can use to call functions defined in the front-end client. So when we run these methods from our application, they're executed on the front end where the user's working. So we can actually create a special module for that. That's what this is, like a source module, and we specify the name of the module, the name of the function in the module that we're wanting to call. If we have any parameters that need to be passed in, we specify those. And if we're expecting any parameters to be returned, we specify that here at the end. So that's a ui.interface.frontCall. So those are executed on the front end. So that's if you want to write your own. So you create your own module with functions that you can use. This next page is talking about a predefined set of functions in a module that our engineers provide called standard. So just FYI, you can already use front calls with the standard module that comes with the software. So when you install Genero, you get a module of predefined functions, and some of these functions, well, here's one you can see here. Some of these are just strictly to do things like copy-paste type operations, copying the contents to the clipboard, copy stuff from the clip, that type of thing. But there's other functions in that standard module as well. So you can check the documentation for that. If you just type in ui.interface.frontCall, you should be able to find references to the standard module, and I know that it lists out all the different functions that you can use. So some additional ui.interface methods. If you take a look at all of these, remember they're all class methods. There's a pair here that you can use to set or get the name of the program. So the set name, you can actually give the program a name, and then get name gets whatever the name currently is. We've got the same type of thing here for set text and get text. So this defines a title for the program, and this get text just returns the title of the program, whatever it already is. If you want to use an icon, an image for your program, you can use the set image, and then you can use the get image to get the name of an icon if there is one currently used. And then you've got the set type to define the type of program. Now here's the UI.window class, and as you can probably guess, this gives us an interface to manipulate window objects. Now there's two different class methods for UI.window. I've already mentioned you've got two different ways that you can get a reference to the current window. You can either specify the name of the window that you want to get a reference to with this forName method, or you can just get a reference to the current window, whatever it is, with the getCurrent class method. So either one of these methods, they're class methods that are used to get that reference to a window so that then you can act on it perhaps with an object method. Now sometimes you don't even want to act on a window. You just need to get a reference to it so that you can get a reference to a form, right? So way down here at the bottom, we've got a window, UI.window object method that we can use to get a reference to the current form. So sometimes we're just getting a reference to the window so that we can do this step to get a reference to the form, and then we can do stuff to the form, like hide stuff on the form, show stuff on the form, and that type of thing. And then we've got other object methods here for UI.window that we can use to get down maybe to even a lower level, like find a certain node. And here's a get node to return the node for the current window. And again, we don't use these methods that often anymore because we have all those UI.interface methods nowadays that we can use to manipulate objects in the forms. Here's the set text and get text, though, that we saw an example of earlier, just to change the title of a window or get the title of a window. So again, I think we've seen this example already, or at least one very similar to it. So here we've got a variable defined as a UI.window object. W is a UI.window object. We're opening our window here with form, and then we're using a class method to get a reference to the current window here and assigning it to our W variable. And now that we have a reference to the current window, we're going to change the title of the window with this object method set text. So here is UI.combo box that we can use to populate a combo box. Now remember, earlier this week we've looked at combo boxes once, and we were just strictly working with the combo box right there in the form. So we went into the form and went to the properties for the combo box form item, and then we went in there and there was an items property, and we can click on the items property and add these combo box items just by editing the properties. So that's a very static way of doing things, and once you start getting into these special methods for combo boxes, now we can start talking about ways to populate the combo box dynamically. So here we're populating the combo box at runtime, so we again can add static items to a combo box through methods, or we can use methods out there and declare a cursor and read combo box items in with a cursor from a database table. Maybe read them into an array and then use some of these special object methods for combo boxes to take the contents of the array and populate the item list in the combo box. So we'll see an example of that here in a minute. So these are all special methods to work with combo boxes. This first one here, let's look at the class methods before I forget. Class method, of course, is to get a reference to a combo box by using the name of the form field. So this for name is looking for the name of the form field that the combo box has been defined on. So that would be like country, right, or whatever the name of the country code is that we looked at earlier. And then the set default initializer is if you want to use a default initializer function for all combo boxes. Now, I would imagine that most of the time your combo boxes, you may have more than one combo box defined. So you would probably use an initializer function that you called after you have a reference to a particular combo box before you would use that. But this would just be kind of like for forms, right? We have that default initializer for forms, and it would do something like load a toolbar for every form that's opened. Well, this is similar, except it's for combo boxes. So anything you would have in that function would need to be, well, just be aware that every combo box will have whatever done to it that's in that function. So I don't know how often you would use this with combo boxes. So here's a clear method that you can use to initialize the combo box items. So if there's anything in there, it would get rid of them. Here's the method to add an item to a combo box. And then there's all kinds of other methods here that you can use to interrogate a combo box to get information about what's in the combo box. So let's look at some examples. Here's an example of defining an initializer function for a combo box. So defining the function first starts out with writing the function. So right down here somebody's written a function called cbinit, and in that function they've defined a variable called cb that's type ui.combobox. And then here, once they have a reference to a combo box, they're using the clear method to initialize it. And then they're very statically adding some items, right? So these are all static items, but it's dynamic in that we're populating the combo box at runtime here versus doing it in the form ahead of time. So a different method of populating. So up here, here's our code. Open window with form, cust form, and then right here we've got let CB equal, and then we've got our class method here to get a reference to a specific combo box. It's the combo box defined on the customer.state form field. So we're getting a reference to that specific combo box, and then we're calling this function, cbinit, and passing this reference to that combo box to the function. And of course we just saw that this function here, now that it has a reference to the combo box, is going to add these items to it. And here is, I would think of as the most dynamic way to load or populate a combo box would be from a database table using a cursor. So here we're loading a combo box from a cursor set. So here's our function, and again we've got some program code out here we can't see that gets a reference to a specific combo box and passes it in, calls this function and passes it into this function. So here in this function now we've got our variable defined as a UI.combo box. We've got a couple of other variables here for state code and state name, because that's probably what we're populating our combo box with, is a state code and a state name. So here we're initializing the combo box, declaring a cursor that we're using to select the state code and state name from the state table with, and then we're just using a for each statement here to read through the rows in the result set with the cursor, and then one at a time using this cb.addItem object method to load that into the combo box. So there's our items for the combo box coming dynamically from a database table. And then here is the UI.form class. This one is one I've mentioned already as being different from most of our different classes, because notice up here in the class methods there isn't a way to get a reference to a form here. So that makes it unusual to me. So there's actually a couple of ways that I can think of off the top of my head to get a reference to a form so that you can use some of these object methods to manipulate items on the form. So one of them is with the UI.window class. We already saw it a minute ago that had an object method that we could use to get a reference to the current form that that window had opened. So that would be a two-stepper, right? We'd have to get a reference to the window, and then we'd have to get a reference to the form that that window had open. And then we could use the object methods. So that's one way, and then we have the UI.dialog method as well to get a reference to a form, because there's no way to do that with the UI.form class itself. So there's only one class method for UI.form, and that's that setDefaultInitializer method that we can use to, when we open a form, we're going to automatically pass that form by reference to the default initializer function. So anything that you want to do with your application to all forms, that's a good place to do it, right, in this special function. All the other methods are object methods. So here are methods, again, we don't use these that often anymore, methods to go out and find a specific node in a form and tags in a form. Nowadays we can replace most of that kind of work with UI.interface. We've got options there with the dialog class too to hide things, show things, enable things, disable things with special methods. So we don't really need to use these lower level methods anymore, like find node, get tag, and so on. People still use them for some things, but it's not that common. What is common though are things like load action defaults, load toolbar, load top menu. Now if you're using these object method techniques to load the action defaults or toolbar or top menu, you're loading them at the form level, right? So this is for the individual form that you have a reference to. So in the case of action defaults or top menus, if you've already used a UI.interface class method to load the top menu or action defaults for the entire interface for all forms, this will override it. So if you use this later with the UI.form method, then it will override anything you've already done at the interface level. An exception, though, is toolbars. So if I've used the UI.interface.loadToolbar command to load a toolbar at the interface level, and then I run a UI.form load toolbar, they stack. So I'll get the interface level toolbar, I think is on the bottom, if I remember right, and in my form level toolbar, I think ends up on top of it. It will actually be stacked. All right, but otherwise, if it's not a toolbar, it actually will take the place of the interface level. Action defaults are top menu. And then here are different methods that you can use to hide and show things in the form, things like labels, form fields. You can apply a style here to a form field with this set field style. Remember when we were looking at presentation styles, we said there's all kinds of ways to apply presentation styles to objects. Well, here's a way right here by using a special method. So we can do this dynamically while the program's running. So here's an example of a method to hide and show something. We've got this UIForm.setElementHidden. So we've got a lot going on here because we're working with form objects. So first we have to get a reference to a window with this UI.window.getCurrent. So we've done that to get a reference to the window, which we've assigned to our variable W. And now that we have a reference to the window, we can use this window method, this is an object method, to get a reference to the form for that current window. So we've assigned that to this variable F, which is a UI.form object. So now we have a reference to the form. So here we have an input by name, and then we've got some buttons or something, some kind of an action view out there that says hide. And if the user triggers that action by pressing the hide button, then we're calling this f.setElementHidden. This is an object method, and we're hiding the customer.storename element on the form. So we're hiding that. The 1 here means hide it, right? SetElementHidden, it's a kind of a Boolean, kind of a toggle. So if it's 1, that means hide it. Then right down here, if the user selects the show button, he triggers the show action, then we're going to show the customer.storename because we're setting it to 0. So SetElementHidden, if we set that to 0, that means we're actually going to show it. So hide or show just by 1 or a 0 using the same method. Well, here we've got this set default initializer. Now we talked about this a couple of times, so this will probably be old news to you now, but the default initializer, remember, works on all forms. So this UI.form.setDefaultInitializer, the one class method that the UI.form class has, and here it's saying, okay, our default initializer function is called init. So down here is our init function. Every time a form is opened, it's going to automatically pass that to the init function by reference. So the init function only does one thing. Here's our reference now to the form with this variable F. So call load top menu, and then the name of the menu we're loading is called my menu. And again, notice we don't have to have the mymenu.4tm, right? We just need the simple name of the top menu there. All right, so I think we've seen a few examples of the UI.dialog class, but the UI.dialog class, of course, gives us an interface to interact with the interactive instructions, right? Like our display array, our menu statements, input statements, and so on. Those are all examples of interactive dialog statements or interactive instructions. So I think we've already talked about the idea that we can use this predefined object variable called dialog to get a reference to the current dialogue. We don't have to use a method. There is one. See this get current? This is a class method that we can use to get a reference to the current dialogue. But most of the time it's just extra work because we have this predefined object variable called dialogue. So we can just use it without having to define any variables. The only place, though, that I can use this predefined object variable is inside of the dialogue block. You remember how in the last chapter we saw the dialogue and end dialogue statements? That's the dialogue block. And you can only use this keyword or predefined variable dialogue inside that dialogue block. If you try to use the word dialogue, dot method name outside of that dialogue block, you'll get a compile time error. But what you can do is you can pass a reference to the dialogue. You can pass this thing as a reference to a function that is outside the dialogue block. So there's a way around it, but you just can't use the word dialogue outside the block. An example of that hopefully on the next page. So here's a class method to get a reference to the current dialogue. Here is a object method to get a reference to the current form. So once you've got a reference to the current dialogue, you can get a reference to the current form. So now we know two methods to get a reference to the form. We have a window method, ui.window method, and we have a ui.dialog method to do it. And then here's some pretty nifty different object methods that we can use to go out and manipulate parts of the user interface, like action, set action hidden. So this will actually hide the action view that you specify by name. So the user, it's not just grayed out, right? It's actually hidden. He doesn't see it at all. And then of course you can show it again. This is that same method that we saw before, hiding an element in a form where it's just basically an integer, 0 or 1, a toggle. So if you want to hide it, it's set to 1. If you want to show it, it's a 0. I have to think every time I say that to make sure I get it in the right order. Same thing here. Now the action, like let's say it's the print action. The print action view would still show up if I made it inactive, but it would be grayed out so that the user can't trigger it. So that's the difference between hidden and active. Hidden, they can't see it at all. Active, they see it, but it's grayed out. So set action active, again, we can true or false, 0 or 1. So if it's active, it's enabled, that would be a 1. If it's a 0, it's inactive, right? It's disabled. They can't trigger it. Same thing with fields. If you want to allow them to enter into fields, to enter data, for example, during an input, you can make the field active or you can make it inactive so that they can't enter into the field and manipulate the field. So that's set field active. That's talking about form fields, right, that we interact with data in. And then I think we've already talked about the set cell attributes once before, but that is for decoration attributes for arrays. Things like setting colors for elements in the array, for example. And this method down here is just to set default unbuffered instead of using the attributes clause. Remember how we've used the attributes clause with various of our, like our input statement, for example, we've used attributes to make it unbuffered. Well, here we can just do this at the very top of a dialogue, like a dialogue statement, and then by default all of the interactive instructions will be unbuffered. All right, so here is a good example of using the UI.dialog methods that we've been talking about. So here we're opening a window, W1, with a form. Here's our menu interactive instruction. Now, what we don't see, though, is up here somewhere there's the word dialogue, and then we've got the word in dialogue somewhere down here. We just don't have room on this slide to show it. So right here we've got our menu statement, and then we have a before menu control block where we're calling this method, dialog.setActionActive. And right there is an example of using this predefined object variable called dialog. So notice we didn't have to do anything to define a variable or anything of that sort. We didn't have to get a reference to it. It's just automatic because we're inside this dialog block that we can't see here. So set action active next, and notice we're just setting that to false here, kind of a toggle, and so it's going to be inactive. In other words, the user, it'll be grayed out, he'll be able to see it, but it's grayed out and he won't be able to click the next button. But then on action find, we're calling a function called queryCust, and if that is successful and returns a query OK status, then we're going to call this dialog.setActionActive, and for the next action, we're going to set that to true. So now that he's done a query and he's had some rows returned from his results set, we're allowing him to interact with that button, right? So we're activating it. So that's a good example of using these dialog level methods and using the keyword dialog or the predefined object variable dialog. Now the OM package is, the package that I mentioned earlier is not used very much anymore. It's a bunch of classes and methods that are designed to interact with the DOM tree, right? The abstract user interface tree that we talk about. So there are classes and methods here that write and read XML that we can use to manipulate the DOM tree. So most of the time nowadays, though, we can do everything we want to do with these different methods we've been looking at, from UI.interface and UI.dialog. There's still a few things that people use these for. It's just not that common. Now the last part of this chapter is talking about these utility functions and some of these special extensions that we have to allow you to use your own libraries or Java classes and instantiate those from your BDL code. So utility functions, we'll start with utility functions. It's just saying up here at the top that these are not built into the runtime system like these built-in classes that we've been looking at so far in this chapter. Right? All those built-in classes are just there. We don't have to load them or import them to use them. But the utility functions we do. Right? So they're not built into the runtime system. So here's this utility library, which is named libfgl4js. It's got some handy functions in it for dialogues. There's like one that you can use to prompt the user for confirmation or prompt the user for input. There's a couple of functions to do that sort of thing here. There's database functions that you can use to start transactions, for example, instead of using the transaction statements that we've seen earlier in class this week. Front-end functions, and then some Windows client function. But you can see in the documentation, you can see all the different functions that are available in this special provided utility library to see if there's any of them that you can make use of. And here's a few of them here. This FGL win message is one of these utility functions that's already written for you that you can use out there just by invoking it to display a message box with choices to the user to pick from. And then there's another one, kind of a similar idea, called FGL win prompt that you can use that displays a dialog box that allows user to input a value. You know, you prompt him for some information and he can enter that value into that window or that dialog box. A couple of database functions here. Here's one to return the type of the current database and another one to start a transaction. We can use that method instead of using the begin work statements that we've talked about earlier this week. And here it's saying that these utility functions, they've been around for a while and we actually have some better ways of doing things now than we do with these utility functions. So it's saying this front calls method that we're using to invoke functions on the front end is a better way of doing things now than using the Windows client-specific utility functions that you'll find documented for this utility. So here we're talking about the Java interface. It's been around for last 3 or 4 versions of Genero, 2 or 3 versions at least. 2.20 is when that started out. And what that allows you to do is import Java classes into your BDL program with the import statement, and then you can instantiate those Java classes from inside the program. So again, all the things you would expect are still there. You have to have the Java development kit on the development system, and then you'd have to have the Java runtime environment installed on your production system to be able to get all that to work right. And then you'd have to import your Java class before you can use it in the BDL program. C extensions, a similar idea. We have C extensions that allow you to integrate your own C libraries in the runtime system. These are implemented as shared objects, so they have to be in the form of an SO for Unix or Linux or a DLL on Windows. And then there's 3 different ways that you can bind your C extensions with the runtime system. The import instruction, like we saw with, for example, with importing a Java class, is one method. You can also just give your C extension library a default name, user extension, and providing it has that name, then we'll bind it with the runtime system. Or you can specify the extension to load with the FGL run that we use to, that's the command we use to run a runnable, an executable program, and you can provide the name of the extension with the -E option in your FGL run. So any of those 3 methods can be used. And here's another C extension library that's provided. It's already provided for you, but you do have to import it to use it because it's not part of the runtime system. It's called the OS extension library, and you can see by looking at it here that it's got a lot of things that I think of in relation to Linux, for example, your Linux, Mac type commands, kind of operating system level commands, which I imagine is why it's called os.path, right? So all of these things are things to manipulate your environment and directory structures and such at the operating system level. So those have to be imported as well before you can use them. And here it's talking about the util package. And this is also provided in the C extension library, the util C extension library. Again, you have to import it to use it, and it provides some handy things for date conversion. There's some special math methods. There's lots of these, by the way, so I'm just showing you a couple of them here, but if you look at the documentation, you'll see that there's lots and lots of mathematical methods that you have access through this util package. And then finally, we also have a util.json class provided by this util package. It's fairly new. This is probably our most recent utility that's provided. It has to do with JSON classes. And so we've got 3 different classes here for working with JSON objects. We have util.json, there's util.json object, and util.json array. And of course you can use the util.json to convert your program variables to and from JSON strings. We've got this interface, this JSON object interface to work with JSON objects, and then similar function for JSON arrays, functionality for JSON arrays. So we have a little example over here of using one of these methods here with the util.json class. The idea here is we've got a record that we want to serialize into a JSON string. So here we've got a variable defined as a string, and then we're just using this util.json.stringify to convert a record called custrec here into a serialized JSON string. So that, of course, the idea there is to make it portable so that maybe we could send that to a different application, for example, and then on that end they could take that and convert it back into a program record if they wanted to, or maybe read it with some other technique or some other program. here is the Lab 5. There's only a couple of things for you to do. One of them is we're going to try some of that special class methods for Windows that we've looked at earlier. So it says modify your query by example application to change the window title to search accounts when the user selects the query option. Right, so that's a big clue. You need to make sure you put it in the right place. And then here's a hint. There's a special object method just for this in the UI.window class. And in exercise 2 is to use a form method to load a toolbar. So the only way we've worked with toolbars so far has been to define them in the form, a static toolbar in the form. So now we're going to use a method to load a toolbar instead. So here's just the instructions on writing down the toolbar items that we've built into the form so that we don't forget what they are. And then we're going to create a new toolbar file and put those toolbar items in the file now instead of in the form itself. And that goes on a little bit. And this is just showing you what your toolbar file might look like. It's an XML file, just like all the other resource files we've talked about this week. And then right down here, we're going to modify the accounts main source module to call an initializer function using the UI.form method. And remember, that's the only class method that UI.form has. It's a set default initializer. And that method works for all forms, right? So anytime a form is opened, they're all going to be sent to this initializer function now being passed by reference. So here it's just giving you instructions. Create that initializer function in a different module, call it global settings, and save it in your query by example application node. So go ahead and put it in the same node, organize it that way, and then execute it and make sure your initializer function runs and loads your toolbar. Now one thing you'll need to do though that I don't remember seeing in here, do I, is you'll need to remove that toolbar from your form. Okay, step 2, right? Delete the toolbar from the form. Otherwise, you won't know if your initializer function works or not because it would already build it in the form because we had it in there. So make sure you delete the toolbar from the form so you can tell if your initializer function works correctly.